All right, good morning, everyone. My name is Randy Becker. I'm the director of our 5G testbed program. I'm from Santa Rosa, California, which is about an hour north of San Francisco. This is where our headquarters is located and where we do a lot of our design and development of our signal generators, spectrum analyzers, and network analyzers, along with software. Today I'm going to talk about 5G, some of the trends, some of the things going on in the industry, and how this relates to the testing of the next generation 5G base stations. So first off, we can see on the left there are a lot of the industry drivers, a lot of data growth in the industry, a lot of devices going to be connected, a lot of new applications. People are starting to use the network in new and different ways, and this is going to lead to the things we need to think about for 5G. So how are we going to get there? So for 5G, people are proposing 100 times the data rates, 1,000 times the capacity, a lot higher densification, lower latency, high reliability, and even more energy efficient networks. These are things you can easily find if you do a little search on Google. But the next question might be, how am I going to actually test these new devices? What are the things that I need to think about? So how will you get there? How will I test these new devices with these new technologies? How will I keep up with the standards as they evolve, right? So just like LTE, 5G will go through many iterations over the next few years. How will I scale my SISO solutions to test beamforming and massive MIMO? How will I test at the higher frequencies like microwave and millimeter wave? Things are quite a bit different than they are at sub 6 gigahertz. How will I verify the performance of my DUT when at the higher frequencies there's no longer antenna connectors available, since the RFICs are mounted right to the antennas? And then how am I going to afford to do all of this with limited OpEx and CapEx budgets? And then lastly, I need to get all of this done and be the first to market so I can be ahead of my competitors and to win in that space. So there's a couple of key trends, key industry insights we can get by looking at a couple of things. So the first, which I think is no surprise, if we think about our cell phone bill, nobody wants to pay more for their cell phone bill, right? Everybody wants higher data rates, but nobody wants to pay more for their cell phone bill. And this is ultimately rolling up into the NEMs having extreme cost pressures, and the having lower priced devices. And this is going to drive down the cost of test. So when we think about the test solutions that we have to offer, they have to be in line with the cost of the equipment that we're testing. There's also this concept of collaborating to market. So if we think about 5G, it's a very complex technology. You, as the people designing the next generation base stations, have core competencies in certain areas, and that's where you're going to be able to provide value and innovate. But there's lots of other challenges that you need to solve. And Keysight, we believe, is uniquely positioned to help you solve many of these challenges that you're going to face. Additionally, the RAN is becoming ever more complex. We have higher frequencies, wider bandwidths, and even new modulation schemes to think about. Having flexibility is going to be very important. The standard is going to continue to evolve. It's going to add new features, new capabilities, and we need solutions that will be able to scale to handle those. And then lastly, how are we going to make these tests over the air? So this is sort of uncharted territory. We need to be able to figure out how to do this without using antenna connectors. So now we'll look at some of the specific 5G test challenges and how this relates to the next generation networks. So on the far right here, I've diagrammed a high-level overview of a 5G base station. So we'll just take a quick look. So we'll see here that the base station has, instead of just a couple of channels, has many channels that could be used for beamforming or even massive MIMO. And one of the particular challenges here is how we're going to make those tests over the air that I mentioned earlier. Additionally, we might need to think about fading, how to simulate these new environments to determine if our device under test is working. And then if we look at the other end of the remote radio head, the connection there is usually some kind of optical connection over some fiber. And it might be useful for testing at this device plane as well. After that, the signals make their way back to the core network, where solutions are being implemented more and more using cloud technologies. So there's a lot of different test challenges when we look at the new base station architecture. And at Keysight, we're doing a couple of different things. So we're designing a new 5G test bed, which is sort of the foundation for testing and generating signals that will communicate with the base station. The base station fundamentally is transmitting and receiving over RF, and we need solutions that can be able to do that. But I've highlighted here in blue on the left, you can see some of the other challenges that I talked about: the front haul, the massive MIMO, channel emulation, OTA. Keysight has specific programs in these different areas, but what I'm talking about today is specifically around the test beds. Okay, so here's a quick look at our next generation test bed for 5G. This is a modular approach, and this leads to several key things that we'll need in the next coming years. So a solution that is very scalable, very flexible, and also very upgradable. Oops, these buttons are a little, I think I'm too far away from the machine. So I won't say too much about this, but you can see some of the important points below. If you want to get details about this, we have a booth over there on the end where we have both our microwave signal generator and microwave signal analyzer set up, and we can go through the details in more at a later time. We also have software solutions. So we have a wide array of software, from early prototyping all the way through manufacturing for 5G, for custom OFDM, pre-5G, and even new radio. But what we'd like to do is wrap all this together into specific solutions for you, to integrate all of the hardware together and into solutions for specific tasks. And then moving more towards software-defined solutions that can operate in the cloud. So the next question you might ask is, well, how am I going to be able to afford this next generation test equipment? So Keysight has a number of different things available. So we have flexible financing, a number of different ways to obtain the equipment. We also have technology refresh programs where you can move your 4G platforms to 5G, and we also have some get-to-market faster programs in place, like training, productivity assistance, and so forth. And lastly, Keysight offers the best combination of hardware, software, and people with the right expertise to give you the insights to get your products designed first and to market fastest. Now, I'm going to stop there, but I'll give you one more sneak peek at some of the things that we're demoing at the test bed at the end of the booth. So just one screenshot of some of the measurements that we're making. So here you can see we have a number of different measurements we're making simultaneously on a pre-5G signal. And the next one here, we're showing a simultaneous 8-component carrier demodulation where we're looking at the constellation diagram, spectrum, and a number of the different EuMW metrics. We're also doing this with a phased array antenna, that we're actually scanning in real time, where we can get the antenna plots. We're not showing that on this screen, but if you want to see that, you can come to the booth at the end of our section here. All right, thank you so much.